Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about the null coalescing operators. These two will let you easily test for null and return a value, or test for null and do some logic. Okay, so the null coalescing operator. Now this one is defined by two question marks, and the simple use case is for testing if something is null, and if so, returning some kind of value. So for example, here we have some kind of string player name, and then we've got a function to get the length of a certain string. This one receives the string as the parameter and just returns the string.length. And then over here, we're trying to get the player name length by passing in the player name onto that one and then printing it out. However, if we run the code like this, without assigning the player name to anything, if there you go, naturally we have a null reference exception. If we don't assign any value to a string, then that one is going to be null. So over here, we can add some kind of a null check. So let's find the player name, then if player name, if it is null, if so, let's put this one equals get the string length and pass in just an empty string. If not, then let's assign the player name length equals our string length. So we do a null check, and depending on that, we get one or the other. So let's see. And if now it does work, so without assigning an actual player name, just return 0. So no more errors. This code is working, and we can do exactly the same thing, but in a more compact manner using the null coalescing operator. The way you use it is, for example, by writing the player name, then two question marks, and then basically here we want whatever this is going to evaluate to if player name is null. So for example, we can do this, meaning that this will either evaluate to player name or an empty string. So if we use this instead and put it over here and just have one of these, yep, just like this. So basically this one, this instruction here, what it does is it evaluates the left side, left to the question marks. And if this one is not null, then this whole thing is going to evaluate to just this value. However, if the left side is null, then this whole thing is going to evaluate to whatever it is on the right side. So basically, if player name is not null, then it's going to call getStringLength with the player name. But if player name is null, then it's going to call getStringLength with an empty string. So now if we test, and if there we go, no errors, and it does return 0. And now if we give the player name something, so let's say code monkey, and if now the exact same code also tests for the null check and now gives me the actual length of the actual string. So here we are doing exactly the same thing we were doing previously with the null checks, but in a much more compact manner. And I can also link multiple of these together. For example, let's define here a string for a default player name, and let's assign it to something. Then over here we can do player name, double question mark, default player name, double question mark, and 0. So you can chain multiple of these together. If we run this code, there you go, it does return 7, which is exactly the length of this string. So basically this is going to execute from left to right. So if this one is not null, then returns this one. But if this one is null, then goes to the next one. And if this one is not null, then returns this one. However, if this one is null and this one is null, then returns this one. So this operator is really useful for very quickly doing a null check and returning a non-null value. Instead of doing if-else testing for null, you can just write this and everything works perfectly. By the way, on the right side, instead of just returning a value, you can also run some logic. So for example, if player name is null, you can throw a custom exception with a custom message. Now the second operator, that one is the null coalescing assignment operator. In terms of syntax, it's exactly the same with double question marks. The only difference is that it has an equals at the end. So for example, if we have some kind of player class and a player field, if we try running some code on the player here, let's just do a player.toString, so let's do a console.writeLine on this. If you do this, then naturally this one will throw a null reference exception because player is indeed null. So as a way of doing some kind of initialization, we can write player, then double question marks equals, and then new player. Basically what this does is it's going to check the player variable. If that one is not null, then nothing happens, just continues executing the code afterwards. However, if player is null, if so, then it's going to construct a brand new player and assign it back onto this variable. So this operator can be really great for initialization. Like for example, let's say the player down here has a list of other players to target. And now usually if you have this kind of thing, you can either initialize this list directly on the constructor. That means that the list will be constructed as soon as the player is spawned. However, you can only initialize it when an enemy is added. So if you have a public void add target player, this one receives a player for the target player. And now here, if you just go player target list and add the target player, if you do this, then naturally this is going to throw a null reference exception because this one does not exist. So before this, you can do double question mark equals new list to initialize the list. So basically, if the left side is already initialized, if this one is not null, then this line of code is going to do nothing. But if the left side, if the list is indeed null, if so, then it's going to evaluate the right side, which is going to construct a brand new list and assign it. So this operator is great for initialization, or really just any kind of null check where you want to run some code only if the left side is null. Also, what we covered in the previous lecture, the non-conditional operator. Like I said, that one returns null if the left side is null. So for example, we can do player then question mark, In order to make sure we run the code on the right side only if it's not null, then call some kind of function like getPlayerName, and then have double question marks and say unknown player. So basically what this is doing is if the player is not null, then it's going to go inside the player object and call getPlayerName is going to return that. However, if the player is null, if so, then this whole thing is going to evaluate into null, and then we have a null, then double question mark and something, so it's basically going to return this one. So if player is null, it's going to return unknown player, but if it is not null, then it's going to return the player name. And by the way, since the whole point of this entire operator, since the point is to do a null check, naturally it can only work on nullable types, like reference types. So if we define an int, if we do this, then naturally this does not work. Whatever's on the left side has to be a nullable type. However, if we make this instead of a regular int into a nullable int, if so, then yep, now this code does indeed work. I'm going to cover nullables in a lecture later on in the advanced section, but basically they allow you to make any type, like a bare bones int, and make it into nullable. So that's the two null coalescing operators, another very compact way of doing a null check, in this case to return some value or do some logic if something is indeed null.